Okay, so this is the notes for 7.2, and what we're doing is we're going from 7.1, we had growth functions, exponential growth functions, where we saw as we went to the right it climbed, or if it was a negative growth function it would be dropping very, very fast as it moved on. But then we're going to be dealing with decay functions, and decay functions tell us that inside of the parenthesis, or the value with the exponent must be less than 1. So because 0.65 is less than 1, we know this is a decay function, and that's 7.2, okay? We're going to use this idea. It's going to be going downward. Start up real spiked, and then it's going to go downward. Okay, so we have the difference between growth and decay being whether or not our inner value is less than 1. Decay functions obviously flatten out to the right, whereas growth functions are flat on the left. And they both have that spike, it's just where does it occur. So let's look at some examples. Number 12 from the textbook asks us to graph g of x equals 2 times 0.75 raised to the x, excuse me. Well, one of the things we want to know is that 0.75 is a value less than 1. So this will be a decay function. Now when I go in and do my x and y chart, I'll start with 0 like before. Anything to the 0 power is 1, and 1 times 2 is 2. So in my graph, I know that 0, 2 is a point that's on my graph. Well, then last time we would have picked 1, but and this one won't be too bad. You know, if I put 1 in, 0.75 to the first power is 0.75, and 0.75 times 2 is 1.5. And so, you know, over here at 1, I'll be at 1.5. But this doesn't quite tell me very much information about what the graph actually looks like. One of the best ways to do it is actually to go backwards, because remember, growth, they shot up when I went to the right. These are going to shoot up as I go to the left. They're going to, increase in size significantly. So let's try -1 and see what happens there. Because right here, the distance between 2 and 1.5 is only 0.5. So we'd like to get a bigger gap there. And so I'm going to take, in my calculator, 2 parentheses 0.75 raised to the negative first power. And negative first power, what it does is it flips fractions upside down. That's really all it's going to do. I end up with 2.6 repeating. This is a 0.6 versus a 0.5. It may not seem like much now, but it's actually going to work out a lot better in the long run. So I'm going to come over here and put that point. And again, I know that these are spiked on the left and that they flatten out as I go to the right, going towards 0. So my domain would still be all reals as compared with 7.1, and the range here is y is bigger than 0, because I never quite come down to 0 for my y value. Then lastly, before I'm done, which again, there's not much new material here, it's just a rehashing of 7.1, we'll do this problem, number 23. Again, I want to get 0 for an exponent. Well, to get 0 for an exponent, I'm going to use -5. And -5, okay, plus 5 is 0, and something to the 0 power is 1. 1 times 6 is 6, minus 2 is 4. Then I have a choice. If I used, let's say, -4, okay, -4 plus 5 is 1. 1/2 to the first power is 1/2, and half of 6 is 3. 3 minus 2 is 1. That works out pretty good. But I could also go to -6. Again, you only need 2 of these points, but if you're finding that one of them is difficult to use, try going the other direction. If I tried -6, -6 plus 5 is -1, and an exponent of a -1 is just a reciprocation. So 1/2 to the negative, so 1/2 to the negative first is equal to 2 over 1 to the positive first. So this is going to be 2 times 6, that's 12, minus 2 is 10. The gap here was only 3, but the gap here was 6. So we just made the gap significantly larger. That's kind of our goal here on a lot of stuff. I'm going to come out here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, you only need 6. You only need 2 of these points, but I'm going to go in and put all 3 of them in. -4, 1 right there, and negative 5, 4 is right about there. So I see this is very steep, and then it'll flatten out. But I also want to take note of this, that down at negative 2 is my new asymptote where I'm going to flatten out. So my graph will look something like this. Okay? The domain, of course, is all reals, and the range, of course, is y bigger than, because I'm going up, negative 2, because that's my bottom line as I identified here, my asymptote. That's it. There's really not much more to it. So good luck, and hopefully you have success.